Welcome back, grade 12 learners. In this video, GMMDC video, we're going to look at circle analytic geometry, and we're going to do the examination type problems, which is part 2. Circle analytical geometry, part 2 of 2, examination type problems. To start off, let's see what we're going to do in this video. Just to recap, we're going to have a brief overview of circle concepts done in video number 1. Then we're going to look at a number of examination type problems and show you the solutions, how to approach them. And then, as usual with all my videos, we have an exercise worksheet. So let's start. So let's start with a brief overview of some essential circle concepts. You don't have to memorize the formula. The formulas for a circle analytical geometry that you'll use, you will always find on the information sheet. But it's important that you understand them and you are able to identify them there. First of all, we have the formula for the equation of a circle with center at the origin. There's the circle and the center is at the origin, and that formula is x squared plus y squared equal to r squared, or r represents the radius. Then we have the other formula here, where the equation of a circle where the center is not the origin, but it's at another point, let's say AB. And there's a situation here. You can see there's the origin and the center is not the origin. And this formula here, as we showed in the previous video, how we derived it, it's x minus a squared plus y minus b squared, where a and b are the coordinates of the center. Let's look at one of the other concepts we did in the first video, and that is to find the center and radius of circles that are given in this form, not the form that's on the information sheet, right? So how do we do that? We want to write this circle equation into this form, and the method that we use there is the method of completing a square. So let's recap that. So there we have it. I'm just color coding so you can see the coordinate of x is there in blue, and the coordinate of the y term there is c, and the constant term is d. So as we said, we'll have a template because you want to write it in that form. So go directly to that form. The only thing you have to be careful of is the signs that you're going to use. So if that's a positive, you'll use a positive there. And if that term, the coefficient of the y is a negative, you'll have a negative term there. So that's important. Don't make mistakes with that. Then we just need to know how to find half of a number. Half of b in this case is b over 2. If it's a numerical value, you'll just simplify it. Half of c, so then because you want to balance the equation, what you add on the left side, you add. So whenever we complete something, you always add, not subtract. So you add a b squared. Then you have half of c, which is c over 2, and again you add. You don't subtract. Don't make a mistake and put down a negative there, because even if I take negative c squared, all squared, it becomes positive. So always when you complete, you add, you never subtract to complete something. Then you just have to calculate that the constant value, and let's say that's constant value. If we assume it becomes the value e. And now we're ready to get the center of the circle. If that's a positive, that becomes a negative. If this is a negative, that becomes a positive. And the radius is the square root of that constant. So r is equal to square root of e. There we have it. Right? Very simple procedure, but an essential procedure that you need to know. Let's look at another concept that we have there to determine whether a given point lies inside, outside, or on a circle. Right? So let's say we have a equation of a circle that is given, and we have to determine whether a particular point, let's say in this case mn, lies inside. So what is the procedure? We just substitute that m and n, that point, into the left hand side of the equation. So let's say we substitute that, and let's say we're calculating that value, it ends up as the value k. So that is a numerical value, you get the numerical value k. Then what we need to do now is we need to compare that k with the r squared, right? So if I get that k value, if this k value, this left hand side after substitute is exactly equal to that r squared, then the mn lies on the circle. Okay, but if this k value is less than that r squared, then that point lies inside the circle. And if k is greater than that r squared, then your point lies outside the circle. Right? So you need to be able to clearly distinguish, know how to distinguish when is it on, inside, or outside. Let's look at another concept. We want to determine if two circles touch or intersect each other. Okay, so let's say there we have two circles, right? I just have two general forms. This circle center is AB with a radius of lowercase r. This circle center is CD with the radius as capital R. So we can clearly just, and I've color coded them. So the one circle is the yellow and the other circle is this blue. So first of all, we need to find the distance between the two circles. And to do that, you need the centers. So there we already have the centers. Let's call the one center M and the other center N, right? So to find the distance, you just use your distance formula. And let's say after calculating that, we find the distance to be a value K, right? So the distance between the two centers in this case is K. Then we need to take the two radii and find the sum of those two radii. So what was the one radius? Lowercase r, and the other one is the uppercase R, right? So that's the R. There we've got them in two colors. So now we just need to compare this K with the sum of the two radii. Okay? And if we notice that these two are exactly the same, in other words, the distance between the centers is exactly equal to the sum of the two radii, then we know that those two circles touch each other, right? And there we have the representation of that. In other words, the distance is exactly the same as the sum of the two radii, so they touch each other. However, if this distance between the centers is more than the sum of the two radii, then the circles don't intersect each other, right? Let's look at it. So you can see there, can you see that distance is more than the sum of the two radii? So those two circles don't intersect. And then we have the last option, when the distance between the two centers is less than the sum, then in this case here, the circles intersect or cut each other. If we just look at it diagrammatically, we can see there, the distance is less than the sum. Therefore, the two circles will intersect each other. And you need to be able to distinguish between these three here. Now let's look at the last concept that we need, the equation of a tangent to a circle, right? There I just have a circle, and I have the circle there is in yellow, and I've got a radius there, which is the dotted line, and I've got a tangent there in that nice magenta color there. And we've got a point of contact, which is at point A. So what's the general approach? That's right. To find the equation of a tangent, there are basically three things you need to do. First of all, we need to find the gradient of the radius, right? Very simple. You just use your gradient formula. Next, we need to know a concept that the gradient and the tangent, the point of contact, are perpendicular. So we need to find the gradient of the tangent using this idea. So if this here is the gradient, we can find if this is positive 3/4, this one will be negative the reciprocal, which is negative 4/3. Or if this is 5, this is negative 1/5. And then just a very simple step, a tangent is that's right, it's a straight line. So it's advisable here then to use this formula. So you can substitute that gradient in there and you use the point. And remember, it must be the point of contact, not this origin, but the MN, and then you just simplify that. And that's the general approach for finding the equation of a tangent to a circle. Now let's look at a few examination type problems and how we go about solving them. Let's look at our first problem. Right, there we have the diagram, and as usual, always try read your question. I've actually pre-read it for you by highlighting some of the key things. Make sure if they give you a point, that C, and that C is there, that M is there, just try to understand your diagram, right? CMD is a diameter, so you highlight it to remind you this is a diameter, right? And you can see E there cuts the y-axis, so you should know what the coordinates be if you have a point on the y-axis. BC is a tangent, so you should know something about tangents and radii. All right. And then we have a few questions here. There are actually 5 questions we're going to look at, and that we'll do in the next slide. But what's important here is to read, and you can even highlight, because if that point C is given, it will have to be used here. If that M is given, it will have to be used. If they mention this is a diameter, you're going to need that concept to be able to answer that. They tell you this is a tangent, so you need to know things about tangents there. Let's look at our first question here. So there we have our diagram. That's the first question. Determine the coordinates of D. Remember from the previous video, coordinates of a point, 2 questions. Where is the D? On the circle. Where else is the D? On the diameter. So that's what we'll use, the circle, the diameter of the circle, to find that coordinate there. So let's look at the diameter. CM is equal to MD. Why? Because they're radii. So let's look at the C and the M. Let's focus on the X coordinate first. A -1 is transformed to a 2. What do we do with -1 to become a +2? Correct, we add a 3. So I have to take 2 plus 3, and then I'll get the D value. So 2 plus 3 is 5. Let's look at the Y coordinate. The 2 is transformed to a 4. So I add a 2. Add another 2. That's 4 plus 2, which is 6. And there's the coordinates of D. It's advisable when you calculate a point, just insert it on your diagram, right? So you don't have to go and look for it again. There's 5 and 6. The second question, determine the equation of a circle. What do we need for the equation of a circle? That's correct. We need a equation of a circle. We need the center, which is given, but we also need the radius. So we have to calculate the radius. Now, how do we calculate the length of a radius? Using the distance formula. Let's apply the distance formula. Very easy in grade 12. That's square root of 13. Now we use the formula for the circle, and that's the center. So I just have to substitute the A and the B value, which in this case is 2 and 4 there. And square root of 13 squared, you don't leave it like that. That becomes 13. So there's the equation of the circle. Again, a question, determine the coordinates of E. Again, where is E? E is on the circle, so I'll have to use the circle. Secondly, where else is E? On the y-axis. What do we know about the y-axis? That's correct. The x value is 0. So I take my circle formula and I'll just make x equal to 0. So x equal to 0, there's a 0 there. And I just do a little bit of numerical calculation. That's 4. Transpose it, that becomes a 9. Then y minus 4 will be equal to plus or minus square root of 9, which is plus or minus 3. There are 2 values. The one value is 3 plus 4 is 7, and negative 3 plus 4 is 1. So that gives me 7, but I want E. So which one is the E? There's E, so E has to be the 7. So E is 0 and 7. And again, let's insert it in the sketch there. So E is 0 and 7. If they wanted the other one down here, that would have been 0 and 1. Now let's look at the 4th question. Yeah. Now you see what's important. If you do calculate values like we had E's coordinate is 0 and 7, then you insert 0 and 7. You might need it. The same way there, if we have D's coordinates, you put D's coordinates in there because you will, in case you need it. So as you calculate, fill in the values on your sketch because you will most probably need it. Determine the equation of a tangent BC. Let's see, so I want this equation. You know the procedure? 3 steps. First, gradient of the radius, which is gradient of MC, which is quite easy, and that gives us a 2. Then I use that gradient to find the gradient of the tangent, because what do I know? Radius and tangent are perpendicular, right? So gradient of the tangent will be, if this is positive 2, that's negative. If this is 2, that's the reciprocal 1 over 2. They're not the same. Then I just have to use my equation for a straight line, substituting the negative half, and I substitute not the 2 and the 4, because the tangent must be at BC, not at M. Be careful there. So you have to substitute M's value. That negative 1 becomes a positive 1. That 2 becomes a negative 2. Then just tidy that up. And there we have the equation of a circle. Negative of x plus 3 over 2, right? Just always verify there. That is negative, and you can see tangent is negative, right? There you have a positive y-intercept, and that also is so you know very well that this answer is definitely a possible correct solution there, right? I mean, without checking, you can just see that's negative, but just be careful with your arithmetic there. Now let's look at the last question. Determine if the circle with center M will intersect another circle. So this circle that we worked out in the previous question, whether it will intersect with the circle with this equation. Now this equation here, it's a new circle. Its center is, that's correct, 5 and negative 6. Right? So this one is 5 and negative 6, and the previous, and there's the center, 2 and 4. We don't even have to calculate, it's already given, 2 and 4. How do we do that? We find the distance between those two centers. And the distance between M and N, in this case, is square root of 109. Maybe you can get the approximate decimal value, 10,44. Then, what else do we need to do? That's correct. We have to add the radii, right? So, there's the one circle, this is the other circle that we had earlier. And you see that was the equation of the circle. So, what is the radius length? Square root of 13. So we take the two radii, which is square root of 13 and 6. We add them, and if you get the decimal value, it's 9,61. Now we need to compare them. We notice that this M is a lot more than the 9,61, right? The distance is a lot greater than their sum. What does that imply? That's correct. If the distance is greater than the sum, then the two circles don't intersect. Now let's look at another problem. There we have a diagram. So we have a circle there. So there's the circle and negative 3 and 1 with center F. So this is the small circle. That's the equation of the smaller circle. And then we have another circle with center G. And it is said here that HG, let's follow that, HG is twice FH. And JH is a common tangent, so it's a tangent to both circles, and JK is another tangent there, JK, and S there we've got the coordinates of S, which is on the smaller circle, which is 6 and 5. So just make sure you see everything, and in a question there, just highlight there. See, I've highlighted it there. It's much easier, so if you miss something, you can always say, oh, I haven't used this, or I forgot about the tangent, or I did not use. So all these are key given information there, key words, key terms that you clues that you will be using. There are 3 questions we're going to look at, and we'll do that on the next. Let's look at our first question again. Very common question. Find the coordinates of F. Now we get used to it. Where is F? F is the center of the circle. So I just need to find the center. So I have to use this circle to answer F there, right? F is on the center. F is the center of the circle. So if this is the equation, what is the center there? The center is 3 and 1. Okay, so there I've got the center 3 and 1. Then the next question here. So I insert the 3 and the 1 in case I need it. Determine the length of HG. Now let's see, where's HG? Remember they said HG is twice FH. So if I know FH, I can find HG. But FH is the same as what? That FH is a radius. FS is also a radius. So if I work out FS, I will get FH. And once I have FH, I can get HG. So we plan actually what we're going to do. So HG is double the FH, which is double the SF, right? So in other words, there's 2, that's the double part. SF is just the distance. I just work out the distance between S and F. That will be 5. So it's 2 times 5, which is equal to 10. So HG is 10. You could also have done it separately, work out the SF separately, which is 5, and then you double it there. Let's look at the next question, and then we put in the 10 there in case we need that again, and the 5. If the equation of JK, so JK is a tangent, right? If that's a tangent there to the circle, it touches there. 22, so I have a 22 there. Determine the coordinate. So I want to go from So what will the coordinates of K be? Can get that, that's 22. So what will K's coordinates? So there's 22, so we can easily find K's coordinates. So, and the radius is 10. If this is 10, this is 10. So if this is 22, I just go back 10, right? So from 22, the x coordinate is 22, so I go 10 back, and that will be, so this m value there would be 22 minus 10, which is 12, right? Now we need to find the coordinates of n, but n is the y value, and this y value here, how do we find that y value? We need to find the distance now. So I need to see what that distance, that is the y value, needs to be calculated. Now I know that distance is 5 and that distance is 10. I have a 3 and a 1, and I have a 12 and an n. So just the n is missing. So I can work out the distance of FG. And how long is FG? FG is 15. So I use the coordinates of F and the coordinates of G. Remember, M is 12, and that's what I get. If I simplify that, if I square both sides, 15 becomes 25, and I do that little bit of arithmetic, it's 9 squared is 81. So I have, so 1 minus n squared is 144. Again, we have 1 minus n is plus or minus square root of 144, which is 12. And then we can get the two n values. N is negative 11 or n is 30. Now, which one is it? Can the n, is the y coordinate a positive or a negative? It's not a positive. So the y coordinate has to be the negative 11. And there we have the coordinates of G. Let's just briefly go over that again. Because that's the x coordinate there is 22, so it's perpendicular. Because the radius and the tangent is perpendicular, so this x coordinate will also be 22. Once I have 22, I can find the coordinates of G. I just go 10 back, so that gives me the 12. Now the only one there is m and n. But these distances that we worked out earlier, FG's distance I know, so I can use the distance formula to solve for n, and that's what we did there. Now let's go to problem 3. Okay, so there we've got our given information, and there's our diagram that is provided. So there I've got an equation, and what does this equation tell you? Without even looking there, you can find the center and you can find the radius. There's coordinates of t. T is a point of contact. There's a point S. It's a point on the circle, and RT is a diameter. What do we know about a diameter and a tangent? That's correct, they're perpendicular. And K is a point that lies here in the 4th quadrant. And KTL, this is a KT is a tangent. Point L is up there. So KT is a tangent there. Now let's look at our questions. So there we have calculate the length of TR. Then we want to find the equation of SR. So we want the equation of that chord of the circle. And then we want to find the coordinates of that point on the circle. And then we have to show that the B is the expression for B. And then we have to find the coordinates of K. Right? Let's go over to the next. It's just that there's the diagram that's provided, and there's the equation that's given. All the other information from the description is already clear there. We've got a tangent, we've got a diameter, we've got 2 points that's given there. So the first question, calculate the length of TR. Let's see, where's TR? There's T and there's R. So that's just the diameter, right? So diameter is twice the radius. And what is my radius here? Radius is square root of 36,25. And I just have to double it. That's very easy. So it's twice the radius. So there's twice, that's the radius. I can read it off from my given equation. And we simplify that, square root of 145. Next question, determine the equation of SR. SR is a straight line. And what do we need for a line? We need a gradient, right? And what else do we need? We need a point. So we've got a point, so I just need the gradient here, the gradient of SR. Now, how are we going to go about that? So what do we know here? We know that angle S is 90 degrees. Why is angle S 90? It's an angle in a semicircle, right? So if I want SR, I can get SR's gradient from, that's correct, from TS. So if I find the gradient of TS, I can use it to find the gradient of SR because TS and SR are perpendicular. So let's find the gradient of TS. Very simple, -5/2. Now, because it's perpendicular, the one is negative, the other one is positive, and I just take the reciprocal of 5/2, which becomes 2/5. Equation, there's the equation formula. So let's substitute the 2/5, and which point? SR, I must use S, right? There's the only point I don't have R's coordinate, so I'm going to use S there. So there we substitute and we simplify by transposing, and then there we get the answer. Y is equal to 2/5x. Okay, that's the equation for SR. Now let's look at 3C. There's the diagram again. Find the coordinates of R. Very common here. Coordinates of a point. Where is the point? R is on the circle. Where else is R? R is on this SR, which we just worked out. Right? We're also on TR, but we know SR. So I can either use SR with the circle, or I can find that. But what is much easier? I have T, and I know the center, and we had a question similar to this earlier. So I can just use the transformation there from T to M and from M to R. So TR, I've got point T, point M we calculated earlier is 9 and 6,5 from the given equation. So R there will be from 3 to 9, I added the 6. So I just add another 6 to the 9. 9 plus 6 is 15. From 7 to that, I subtracted 0,5. So 6,5 subtract 0,5. That gives me 6. So the coordinates of R here is 15 and 6. Now we have to show that B is 12A subtract 29. 12A minus 29. So I have to see now B. Where is this B? So I have to use this. And this is part of the tangent. Right? So if I can get the equation of the tangent, right? So I need to use the tangent to get that. To work out that B, I definitely need to use the tangent. So let's see what we can do here. TR I know is perpendicular to TK because the diameter and the tangent are perpendicular. Okay. So if we find the gradient of TR, which should be very easy, gradient of TR. So I use point R and point T, and that gives me a -1/12. Then to get the gradient of the tangent, that is going to be, now I can use my A and my B. So that's 7 minus B over 3 minus A, right? But we know the TR and the TK are perpendicular. So if this one's gradient is -1/12, what will this one be? That's correct, +12/1 or +12. So in other words, I know 7 minus B should be +12. Then we can cross multiply. Then I get that. And because they want make B the subject, and if I make B the subject of the formula, let's first expand that. 36 minus 12A, and make B the subject, and there's B equal to 12A minus 29, right? So I can see, to work out this, where's this B? This B is on the tangent, so I need the tangent to solve that, right? And then we can see tangent. How do I find the tangent's equation? I can use the gradient of the radius. Now let's look at the last question of this problem. There we have our diagram again. 15 and 16, and TK is equal to, this is now something given now, TK, so TK's length is equal to TR's length, right? That means the lengths are equal. So I've got T's coordinate, I've got K's coordinate and R's coordinate. That should be quite easy. The only thing is, I know B, but I don't know, I know the relationship between A and B. So T is 3 and 7, and R is 15 and 6. And TR's length, we worked it out earlier, TR's length is square root of 145. But TK's length, you can find the distance of TK. And TK's length, using the T and the K, I get square root of 145. And you know, there are equal. So TK is equal to TR. It's a given information there. And now I can simplify, get rid of the square roots both sides. I end up with that expression. Then now we have from our previous problem, we had the relationship between B and A. B is equal to 12A minus 29. I can solve this simultaneously. Otherwise, I replace the B by a 12A minus 29. Can simplify that, expand all of that. I get a trinomial, and there you can solve the trinomial. Quite a few steps involved there. We're not going to leave that. Different ways of solving a trinomial, either factorizing or using the formula. And if I solve that, A is equal to 2. So now is A the 2 or is A the 4? I can see here, if this coordinate here is 3, this A is on the left of 3, so it can't be the 4. So A has to be that, right? So I'm going to, and then the B coordinate there will be negative 5, because remember we're on the coordinates of D, so K there will be the 2 and the negative 5, not the 4, because I can see there, that point of contact there is at 3, and this is to the left of it, so it will be 2 and negative 5. Now let's look at problem 4. There we've got the given information, and that's the diagram. So again, let's, as usual, read Q52. So there's point Q, and that's the center of the circle, right? And the circle is PRS, so that's the name of the circle. And P is a point on the y-axis, 0 and 6. We have that. APB is a tangent, so APB, that's a tangent. That's that purple line there. P cuts the x-axis at point B, so that's the x-intercept. And we've got an angle of alpha there with the tangent, and angle R is theta, right? So that's all the information. So we understand a very simple question. We have a center, we've got a tangent at a point, we've got an angle there inside that angle R, and we've got a x-intercepts there, right? And then we've got S also, which is a y-intercept. Let's see the questions that we have there. This is going to be 5 questions, 6 questions, and we're going to look at each one individually in the following slides. Let's look at the first question there. There's our diagram. Determine the equation of a circle. So what do we need for an equation? We need a center, which we have, which is point Q, but we need a radius length. So we just have to work out the radius length first. So there I've got the center, which is at 5, 2. So R is missing. And R I can get using my distance formula, right? So that's the distance between P and Q. So I can calculate R, and R squared is 41. There I've got the equation of the circle. I use the formula, that is x minus 5, because the center is at Q, 2, and there's the equation of the circle with center Q. Very straightforward there. B, calculate the coordinates of S. Usual. Where is S? S is on the circle. Second question, where else is S? On the y-axis. So I must use my circle. And what do I know about a point on the y-axis? The y-intercept, x is 0. So I just make x equal to 0. So that x is a 0. Simplify that. That's 25. Transpose it. That gives me 16. I get 2 values there. Y minus 2 is plus or minus square root of 16, which is plus or minus 4. We have 2 options, 4 plus 2, which is 6, and negative 4 plus 2, which is negative 2. Now, which one is S, right? So we already have P, so S has to be the negative 2. So S is 0 and negative 2. And then as usual, just insert it in your diagram. So if you need it for the next part of the question, you don't have to go and look amongst your calculations here. So let's go to the next question. Now let's look at number 4C. There's our diagram. That's the coordinates of S that we calculated. And let's see. We want to find the equation of a tangent. Basic question here. Equation of a tangent. What do we need for the equation of a tangent? That's correct. We need the gradient of the radius, and the radius is PQ. So let's find the gradient of the radius, which is negative 4 over 5. And we use that because the radius and the tangent are perpendicular. So the gradient of the tangent there would be positive 5 over 4. We then use our formula. The gradient point form of the formula. Substitute the gradient, and it's at the contact point P, which is 0 and 6. So there's the equation, 5 over 4x plus 6. Calculate the size of alpha. Let's see, where's the alpha? There's the alpha. So alpha is this angle between the x-axis and the tangent. So if I get the gradient of the tangent is 5 over 4. So tangent of alpha is equal to 5 over 4. Therefore, alpha is equal to the inverse tan of 5 over 4, or arctan of 5 over 4, which in this case is approximately 51,34. Now let's look at the next question here, number E. Calculate the size of theta. Let's see where there is theta. Theta is here in the circle. Let's see which circle theorem. That theta, it's subtended by this chord, PS. And there's a PS and there's a tangent. So if I can find this angle here, angle BPS, then I have that angle. BPS, I just worked out alpha, 51,34. The axis there is 90, so I can just use sum of the angles, and once I get this angle, it's going to be my theta. So in other words, this theta is equal to angle BPS. And BPS I can get from sum of the angles of a triangle. It's 90 minus the alpha, which is 90 minus 51,4, which gives me 38,66. So alpha is 38,66. I just use one of my circle theorem, the tangent chord theorem there. Now F, we want the area of PQS. Let's see where's PQS. P, Q, and S. Let's just have that diagram there, PQS. So PQ's length from the origin to that is 6, and from the origin to S is 2. 6 plus 2, so PS is 8. So the height is this distance across there, and that distance there is 5. So I just substitute half base times height, which is half 8 times 5, which is equal to 20 square units. Now let's look at our last problem, problem 5. Let's see what is given here. We've got a point M. There's point M, which is the center of the circle. We've got a circle KNAB. Let's see KNAB. Those are the points on the circle. And it touches the y-axis. So it touches the y-axis. The y-axis is a tangent. And it intersects the x-axis there at point A and point B. There's the x-axis. SKL, this here is a tangent. And PBL, there's another tangent there. So that circle is actually inscribed in a triangle. And also SKL is parallel to the x-axis. Let's look at the questions that we have there. There's going to be 4 questions, and we'll do the solutions of those questions in the next slide. Okay, so it helps if you highlight. You see, like I've highlighted that, it's easier. There's a point touching, and you've got tangents all over here, so that's very important that you need to note that. Now let's look at the first question there. There's our diagram again. Determine the equation of a circle. Straightforward, we need the radius and we need the center. We have a center, but we don't have the radius. So let's see, how can we find the radius? Where can we name some radii there? There's radius km. I don't see how I can get that there. I've got radius mb. I don't have the radius. I don't have point B. And I have radius ma. But look at this one, mn. I know that length. That's the length from the y-axis to point M. So that will be 5. The x value there is, so the radius is 5. So you just have to interpret your diagram there. So once I have the radius and the center, it's just a matter of substituting into the circle formula. So that's going to be x minus 5, y minus 4, or both all squared, equal to 5 squared, which is 25. Calculate the coordinates of A and B. Now we ask ourselves again, where is A and where is B? A is on the circle, B is on the circle. Where else are they? They're on the x-axis. So I need to use my circle equation. And what do we know about points on the x-axis? That's correct. The y coordinate is 0. So if I make the y coordinate, that y coordinate makes 0. I can simplify that. That's 16. I transpose it there. I get 9. So x minus 5 is plus or minus 3. And then I get two values, 3 plus 5, which is 8, and negative 3 plus 5, which is 2. Now, which one is the A and which one is the B? So there's A comes before B, so A will be the 2, so that's 2 and 0. There's 2 and 0. B will be the 8 and 0, and let's put the 8 and 0 in there. There we've answered. It helps to put those values, you might need them later. Now let's look at our next question. Write down. See, write down means it shouldn't be that difficult. The SKL, remember SKL is parallel. So it has the same, the gradient, because it's parallel to the x-axis, its gradient is 0. So I just need to get y equal to, what is the y? So if I can get k's coordinates, you know what's the radius here? The radius is 5. So the coordinates of k would be, it has the same x coordinate as the m. So that's perpendicular. So it'll be 5. So I go 5 up. 4 plus 5 is 9. So the coordinates of k is 5, 9. And let's insert the coordinates of, now I can get my equation of SKL. It's a horizontal line, so it'll just have a y value. Y is equal to 9. Right? That's why I get the 9 from. It's that 4 plus that 5, exactly the same that I have there. Now let's look at question 5D. Determine the equation of PBL. Let's see, where's PBL? That's the tangent. Very standard procedure. Find the gradient of the radius, then use it to find the gradient of the tangent, and then just find the equation. Gradient of the radius is negative 4 over 3, which is the gradient of MB. And the gradient of BL is going to be the negative reciprocal of that. So that would be, that's negative, this becomes positive, and the reciprocal of that is 3 over 4. There's the equation. Let's substitute. I have to substitute point B, which is 8 and 0. And if we simplify that, the equation of PBL is 3/4 x minus y equal to 3/4 x minus 6. Now let's look at our last question. Determine the coordinates of L. Where is L? There's L. Where is it? It's on SKL. Where else is it? Always twice. It's on PBL. And what is L? L is the point of intersection. What do we do with our point? We have to solve simultaneously. SKL, we worked it out in the previous question. SKL's equation is y equal to 9. PBL, we just worked out it is y equal to 3/4 x minus 6. So to solve this simultaneous, a very easy one. Just make y a 9. If I do that, then we can simplify, you know, with fractions. Maybe multiply everything by 4, makes it a lot easier. So 4 times 9 is 36. That's 3x. 4 times 6 is 24. So I can calculate x, which is 20. But we want coordinates. So if x is 20, we already know y is 9. So the coordinate of L is 20. Now we come to the most important part. This is the exercise worksheet. But before you proceed with this exercise worksheet, always go through the examples again, but try to do it on your own. Don't just view it or watch it or listen to it. You actually try to do it on your own. Then you'll start with the exercises there. Now let's look at the first one. If we look at that, there's a diagram. They want coordinates of C, lengths, equations of circle, equations of, you know, to what we've done before. You see coordinates of a point, equation of a tangent, lengths, you know, find equations of circles. But if we look at this question again something, same type of question. They give reasons why TS is perpendicular. Find the equation of the line MP. Find the equation of tangents. Find lengths, you know. But important here is always read your question, maybe highlight the given information, make note of important statements there, like NS equal to PS, then you'll be able to answer this here. Good. And as I said before, if you calculate something, fill it in. Calculate something else, especially coordinates, fill it in, because you might need it for later work. Thank you for viewing this video. Also request that you also view part 2 of this topic on circle analytical geometry, in which we have a few more challenging questions on circle analytical geometry. You're also advised to refer to the other CAPS mathematics topics such as calculus. There are 5 videos. Finance, there are 3 videos, and then there's also a video on inverse functions, as well as other videos that will be uploaded soon. Please subscribe to our channel, so if there's any new postings, then you will be notified. Thank you very much.